Let's get to today's program. I'm excited to have with us today Artem Kuprinev from Augury. He's the Vice President of Strategy, and Diego Cantanalo from also from Augury. He is their Reliability Success Manager. I've known this Artem and his team from Augury for many years. They are frequent contributors to the Reliability Web body of content, always bringing great information, and most importantly, real life case studies from the front lines of what's happening out there. So we're excited to have them join the webinar today. Artem, I'm going to turn it over to you and to guide the presentation and take us into today's material. Welcome.
Bob, thank you so much for having us, and all the friends that we have at Reliability Web. Thank you so much for hosting us. And everyone, of course, that signed up and is participating. It's an honor to talk a little bit about the journey that we have and also the impact of AI on reliability. Bob, can I still steal your joke?
Yes, please.
So yeah, it's April Fool's Day. So just making sure that you understand that everything we're talking about here is real. It's not a joke. These are serious issues, but happy April Fool's Day, everyone. So let me share my screen and we'll kick this off. Okay, so we're talking about impact of AI and reliability. We have some experience with that, having pioneered the space of AI and reliability some over a decade ago, some 12 to 13 years ago. And would like to share some of our experience in working with some of the largest or leading manufacturers in the space. We've already done the intro, so let's just go directly to the agenda. So we'll talk about the impact of machine health by first introducing machine health and kind of what Augury has done with some of our customers. And then we'll go deeper into how is this actually achieved, right? What is the impact of AI? First, we'll talk about hybrid AI for machine diagnostics, which is really the bread and butter of what we do and how we work with our customers. And then we'll start looking forward in what does the future bring. Some of the things that we're developing right now and are already out around expert AI agents that take machine diagnostics to a completely different level, making sure that maintenance and reliability teams are able to actually rely on AI for more strategic work. And then we'll get into Q&A. So first of all, let's start with the mission. We work with leading manufacturers. We work with machines. We work with some of the heaviest industries and also some of the lighter industries in the world. And it comes down to making machines smart, but really the impact of that is on people. And how do we make sure that people and machines work together better for the outcome of better productivity across the industry and just making everyone's life better in general? That is the mission, the core of what we do. The technology really drives human productivity and not the other way around. And when we think about what we're doing today, we kind of have two sections, two parts of our offerings, our product. And one is machine health, which is geared towards maintenance and reliability. But the other part is around process engineering. And we do this with a vision in mind that first of all, you need to use AI to really optimize how maintenance and reliability works to make sure that you know exactly what's happening with your machines. And then you move from being reactive to being proactive, to being condition-based, prescriptive, and even beyond that, once you start tying the maintenance insights with the process engineering insights that we provide, you can actually transition into a space that we call reliability-driven maintenance, or to be more accurate, production-driven maintenance. So moving kind of from condition-based maintenance into production-driven maintenance and operations. And this is why it's so important to understand both maintenance issues and process issues in real time, because once you tie them together, you can actually drive work to your production goals and objectives, and not just to the condition of the machine or the budget that you have, but to really achieve the goals for the whole manufacturing organization together. So that's kind of the vision of where we're going and the products that we're developing in this space. But today we'll focus primarily on machine health. And machine health starts with coverage. What do we mean by coverage? Coverage is really taking every type of asset that is critical or even less critical for your operation and making sure that every component, every part of that asset is monitored properly across all the different levels of criticality, whether it's supporting equipment route-based or the hypercritical assets that you have. The other piece of coverage includes the different types of approaches to predictive maintenance, prescriptive maintenance, and reliability. Whether it's vibration and magnetic data that's taken in, or ultrasound, which is one of the things that we recently introduced as a solution for ultra low RPM assets, or it's lubrication, or taking in operational data in order to diagnose assets. All those different types of approaches needs to be covered and then tied into a single platform that provides fully prescriptive insights for all the different components that you have across the factory, across the plant floor. And this is really 360-degree coverage that we aim to cover every single machine that matters for your operation. And we've been doing this for a little while. Some of the customers that we have are leading manufacturers across the globe. Some of our customers have hundreds of sites where we're present. And over the last decade or so, we've come to a place where we really cover a range of different industries that we can learn from, and also enable customers from one industry to learn from a different industry. So whether we're covering food and beverage, or chemicals, or oil and gas, plastics, building materials, cement, paper, wood, other types of industries, you name it, machines operate under different circumstances, different conditions, but all that learning and capabilities is then utilized by AI to provide the benefit for all the different customers at once, right? And so today we drive thousands of maintenance actions and operations every day. Thousands of machines are being bettered, right, and improved through these insights, and hundreds and thousands of maintenance teams rely on these insights for their daily workflows. And so now we can look across the impact that we're having together with our customers, and not just look at the impact from a few pilots or a few initial deployments across customers, but customers that we've had for 6, 7, 8 years, and really understand what happens at scale, what happens once you deploy AI-driven maintenance and reliability across 10, 20, 50, 60, 100 different plants over a number of different years. And the impact is really significant. So whether it's reliability impact, or impact on the maintenance team and asset care budgets, or its impact directly on production, where we're eliminating process waste or increasing yield as much as 9% per shift, or impact on sustainability, that also becomes very significant over time and at a larger scale. But let's dive into what that impact looks like specifically for reliability over time. And what we're seeing is a type of a flywheel, kind of a virtuous cycle of improvement that happens over time. So first of all, when we come in and we're deployed on a site with machine health, typically 30 to 40% of assets have some types of issues that customers don't really know about because they have no other means of identifying those issues. And as they start doing the work to improve those issues, they also increase the coverage of the number of machines that they have. So they go from a certain number of machines and then increase that over time, over a few months or years. We're seeing as much as 90% reduction in unplanned downtime, and much higher mean time between failures. So the assets are becoming healthier as coverage increases, but that also creates trust within the maintenance and reliability team. So remember, this is all AI-driven prescriptive insights. So we're kind of introducing AI into the machine space, and as asset health improves, the engagement and the mean time to repair improves as well. And improves dramatically because maintenance teams, reliability teams start trusting those insights, relying on them every day, and then they start fixing issues way before it's too late. So it's much easier work, as you know, to fix something before it's more severe, and that work is done much quicker, right? So as that happens and engagement increases, now we start having real productivity impact. dramatically lower costs for repairs, for maintenance. Some of our customers are going under the maintenance budget because they had so much issues previously, and that has a direct impact on maintenance productivity. So the same maintenance teams are now able to do as much as double the work or even more with the same resources. And that, of course, leads to direct efficiency improvements for the company, for the manufacturing operation. So we're seeing dramatic increases in OEE, increased capacity. So for some of our customers, 10 to 20% capacity is as much as 5 to 15 plants of additional capacity across our operation. And then single percentage points of total efficiency. But when we talk about total efficiency, that is top line and bottom line for the whole company. And some of our customers are billion-dollar manufacturers. That's very significant as well. And that is a virtuous cycle of improvement that starts with improving machine health. And as coverage increases to more and more and more assets, we're seeing maintenance teams transition to going from being reactive time-based to being fully condition-based, prescriptive, and then eventually starting to become what we call production-led or production-based maintenance. That's the flywheel. But what's important here, beyond the metrics and the impact at scale, is what's the impact on the team itself. So I have a short video I'll share right now. This is a maintenance manager from a large paper and tissue manufacturer. And that person has seen his team go from, a good number of people to just a few people and then just him by himself within his area. But then when Augury came in, which was a time when he was about to retire, that had a significant, tremendous impact on how he perceives his own operation and how he perceives his work. So let's just listen to it for a minute.
Good morning. I've been in maintenance here for 28 years. Prior to Augury coming in here, there was 2 or 3 mechanics in our paper machine area. The last couple of years, we're down to 1 in my area, and I'm the only one. So since then, Augury came in, and it's been a blessing, where I spent hours and hours up on the machines, checking out rolls, checking out all the other information I could gather in my rounds. It was a lengthy job. So now in the mornings, I get on a computer and I check the Augury platform out. I'm always on there looking on my break times, lunch times, whenever, checking out my machines to save me time. This has been probably the best thing that's ever happened to this maintenance department since I've been here in the 28 years. It's really enlightened this whole place and saved us a lot of time and money. We'd really actually be lost if we didn't have Augury in here. Thank you very much.
So, typically the stories that we hear or the anxieties that we hear is, the AI and reliability and manufacturing. The stories are around, oh, is this going to take our jobs? But the stories that we hear from our customers much more often are stories of, well, this is one of the best things that has happened that has really helped turn, a maintenance team that has been really down in the route completely around by introducing this type of technology, adopting it, and really changing the way they work. And this is really what provides a ton of satisfaction in what we do in creating these types of solutions and working with our customers. So now we're going to dive in a little bit deeper into, well, how's this really achieved? I'll introduce just a little bit around machine health, and we'll hand it off to Diego to continue. So when we focus on machine health, that's machine health as a solution that's infused with AI, but there's also sensors that are deployed in machines, and kind of the full service is provided to the customer, so that the customers don't really have to buy or maintain their own sensing capabilities. We come in and provide that service for them. And it's a full stack solution that's also guaranteed to work. So we actually have a diagnostic guarantee where if, let's say, an asset fails on our watch and we misdiagnosed it, we have a program that can pay to repair or replace that asset. And that's provided in the conjunction with one of the largest reinsurance companies in the industrial space, HSB. In terms of the capabilities behind the scenes, there's a huge database of diagnosed machines, hundreds of millions of hours, that actually enable us to provide world-class accuracy, detection accuracy that's well beyond the capacity of a single person, or even any kind of solution that's out there. That's over 99.9%, which means that there's almost zero noise for the people on the production floor. The reliability insights are extremely well trusted. And when we say that there's an issue and we say specifically what it is and how to fix it, the majority of reliability teams then go into the work and find out that that is exactly as has been diagnosed. This also enables us to provide a single kind of day time to insight right after deployment. So in the first hour after the sensors are deployed, in this case, for machine health, we can tell you exactly what's wrong with all the machines that are being deployed, and how to fix those machines. So that is kind of the advantage of the technology that has been built up over many, many years. And we are glad to be innovating in the space together with the customers. Let me now hand this off to Diego to talk about a specific use case.
Hi, everybody. You can click through, Artem. First of all, it's a pleasure being here talking to everybody. So I'm a reliability success manager at Augury, and I think what I want everybody to understand is that, there's a big team of reliability experts on this side. And so we wanted to really showcase how the artificial intelligence works in conjunction with that team. And so I want to introduce to you guys the hybrid AI model that we have for machine diagnostics. It really comes with three main features for the AI, which is the fault detection, the anomaly detection, and then a sense of severity. And I want to walk you guys through an example of exactly what that means. But there is a team of people like me, and all of our customers at Augury have a dedicated reliability success manager on the account that is there really to ensure success, to guide you through your reliability journey and leverage all of our experience to help any reliability team at any stage of their maturity. So let's walk through the example and kind of give you guys a sense of how this works. On the slide right now is our platform. And there are so many different aspects of the platform that I would need about 2 hours to cover them. It's easily digestible, but the information is compact and it's a lot. So I really wanted to boil it down to two main features that I think are the main value for my customers. The first is what we call our fault card. And so when we talk about, okay, but like, how do I interact with this AI? How do I interact with Augury? It usually first arrives to you in the form of a fault card. This fault card has a couple aspects. The first is the machine health level. So you can see in this case, we have a danger status, which is one of our actionable. It's actually our highest alarm status. And then it also comes with, well, what is the fault? What is the suspected fault in this equipment? In this case here, it's a motor that it's experiencing some balance issues and some structural mechanical looseness. We pair that with all of the possible causes and recommended actions that we believe in are leveraging our experience, things to check, inspections to perform. And Artem will actually cover, we can aid you in writing the work order to even action this fault card. But it is here in our platform for you to easily digest. But we are human, go back one. And we need a conversation sometimes, right? We need to have a back and forth with somebody. We need to ask clarifying questions. We need to maybe ask for a deeper insight. And so our platform enables a sort of chat with the vibration analyst. Most of the time, it's the person that put the machine into the alarm or danger status in the first place. And so you can ask questions. You could even, my customers reach out to me directly through this event timeline. And so you're chatting with a reliability expert who's leveraging all of the insight from the AI to deliver value straight to you. So jumping into an actual example, now that we've seen the platform, I want to talk through one of two examples. The first is what we would consider our bread and butter, right? The things that we see every day across tens of thousands of machines, the kind of low human touch point, where the technology is doing most of the heavy lifting, and really we're delivering value very quickly and seeing success very fast. So on this machine, we have a dicer for one of our pet food manufacturers. And you can kind of see on this event timeline that for the majority of the time, we believe that this equipment is in a healthy, acceptable status. And for this couple of days in the month of February, just this past month, well, I guess it's 2 months now, we did have an alarm come up where we saw anomalous data. So let's kind of walk through what happened. It starts with anomaly detection. It always starts with anomaly detection. So our sensors are capturing data, and every single time the next data point comes in, we compare it to historical. Now, we don't necessarily baseline. We'll talk about that a little bit, but we do like to look at the trends. And so we've got very sophisticated anomaly detection. I think it's very clear in this example. I think anybody with any level of training can see that something has changed for some period of time on this equipment. It happens to be at the motor non-drive end in this time. Paired with that, the technology is also giving us insight as to what the actual fault condition is. In this case, we're showcasing structural looseness, bearing wear, and a balance issue. And you can clearly see that the fault probability is highest for the structural looseness. And so that gets delivered to our team along with the anomaly detection. And lastly, it's severity, right? Like, okay, something has changed, but what sort of reaction do I need to have to this? And so we're getting from the technology some form of severity. Package all of this together. A vibration analyst reviews this data, confirms its accuracy, pushes it off to you, and we'll just kind of step through what that looks like on your end. So first, next slide. We package it all up into a fault card. And so this gets delivered straight to your team, symptoms, recommended actions, and then we kind of wait for the customer to respond and acknowledge this alarm. In this case, they did that fairly quickly. The following morning, they let us know that they can stop the machine, they replace the drive belt in the shaft, and they've asked us for validation of that repair. We do that fairly easily because the data, again, continues flowing in. And then we let the customer know, hey, we can move this back down to an acceptable status. The repair has been validated and everything has come back down to the acceptable limits. So that's kind of full circle. Our platform also enables the quantification of this. So, this is all the customer communicating the value that they received. They give us this information. So in this case, you can see 4 hours of unexpected downtime was avoided and about $40,000. And again, this information is provided by the customer, from the customer to us. We just provide a good place to store that information. So that's kind of the 90 to 90, 95% of the time, these are the types of detections that we're seeing. But all of you guys are in manufacturing, you know that bad actors exist, recurring issues exist, and sometimes it's just not that simple. And so I wanted to kind of run you through the other 10% of the time. And this is the 10% of the time that I really focus my day on. And it's really trying to help customers like, okay, how do we move past celebrating the failures and move towards true reliability? How do we address recurring issues and not just continually perform maintenance activities over and over again on our most critical pieces of equipment? In this example, this machine over the course of 3-4 years had several events that Augury caught, but my job is to really start to understand, well, how do we design out the problem? You can see that over the first 2 years, we had 10 major repairs on this piece of equipment, I believe is a fan. And then over time, we were able to kind of dial in our practices, maybe change some specifications of the components, and kind of walk to a place where we feel like the equipment is in a healthy, sustainable, acceptable status. In this case, it was a shaft clearance problem. And also we were using split bearings. The site was using split bearings that were not spec'd to the application of the fan. We also try to have conversations around precision maintenance. So we drive better culture. We try to showcase the value of running the program in a way that is very easily defended by the data. So, we challenge our customers to use precision maintenance practices and then really highlight the difference that it makes in the data and how we can see that. So this is where I focus most of my time. Like I said, all customers at Augury receive a reliability success manager who is doing this for their accounts, very powered by AI. So then the question is kind of like, what is the role, right? You can click here, Artem. And I think really it's, how do we get better, right? How do we move past just celebrating the failures? How do we get to root cause? How do we leverage data and insights, AI and algorithms to show us things that as humans we maybe have a tough time correlating? And the data really creates superhumans. It allows us to see things. It allows us to see more things than we could probably focus on. And you really have that human element. It truly is a hybrid approach where you're having these people that you can speak to. They're leveraging their insight and their expertise and really trying to drive a cultural change with maintenance teams. And, that's the reason I love working at Augury. I love talking to people and I love helping these teams. I'll hand it back over to Artem, but I'd be happy to take questions at the end. Go ahead, Artem.
Hey, thank you so much, Diego. And I think that this just shows the point, when we started with this and we said, there are, experts with 20 years of experience, Cat4 vibration analysts or, reliability experts, that if they were able to watch every machine 24/7, 365 days a year, right? What would be the outcome for reliability? And this is really the premise on which we built Machine Health. And now we can do that. Right, we can provide the highest level of diagnostics for every component across the plant, across the factory. That would take an army of experts, sleepless nights and constantly looking at the data to be able to do that all the time. And I think this is that's the deal, and that's the goal. So we're looking at that for diagnostics. How do we make sure that every machine is monitored and diagnosed at world-class level constantly, without kind of rest, without sleep, across tens of thousands, hundreds of thousands, millions of pieces of equipment. And so we can deliver that same level of insight for every customer every day. But how do we take that into this next realm of maintenance strategy, reliability strategy, understanding how to manage your operation between maintenance and process maintenance and operations in general, how to improve the skill set of your maintenance team. And this is where we're going next in terms of machine intelligence, right? So what we're developing today and have, already released to a good number of our customers is these agents that become smarter and smarter and better around helping more strategic insights, for reliability maintenance diagnostics to come to life. And let me give you just a short example, kind of what that looks like. So first of all, we believe that when you have AI capabilities that are that smart, you can actually give it tasks to help you plan your day, right? And help you kind of get a guided workflow on what needs to be done. What do you actually need to look at, so you don't have to spend hours on the platform to figure out your priorities, but it can just gives you your priorities right away, right? So here's an example where the AI agent tells you, well, you need to review your critical machines, approve work orders, review impact metrics, and get some deeper reliability insights. And as a maintenance manager or reliability manager, you can actually do that quite easily. And this will save you a tremendous amount of work by just focusing your attention on the right things and doing a lot of the things for you in the background. So for instance, reviewing critical machines, there are hundreds of assets that you might need to look at, but these three are the top ones that you need to prioritize. And maybe the rest of them really can be done automatically or can be postponed for later in the day or later in the week. But these three require immediate attention. You need to create work orders, and the platform can actually generate the work order for you and then put that through integration into your CMMS platform, your EAM platform, and then actually track the completion of those work orders so that you can see that not only was the work done, but what were the insights driven from that work itself. Any investigation that was completed that goes back to the AI to understand, deeper root causes, but also whether that work that in the previous example that Diego showed, whether that work was actually successful. You can get immediate feedback on the repairs that were done by the maintenance team, bearing replacement, or any other type of repair. Did it have a real impact on the machine? And you can also track the impact of that, whether it's financial or in terms of time, labor, materials, automatically right away. So the agent would do a lot of that work for you, so you can focus for just on the right things. And it could also provide you, deeper reliability insights that I'll show you what those look like as well. So here's just a different view of what that looks like. But here on the right side, you can actually see when I'm looking at this machine, it provides me a quick summary of what are the specific issues. You can see them in the fault card. But what is the recommended action that is specific to the work order, whether you start an investigation to really understand what's behind it, or you actually generate a full work order for replacement of spare parts. In this case, it's replacement of the bearings. You can actually do that through with the help of this AI agent. Another thing that's really exciting is more strategic view, right? It's kind of more strategic insights into your reliability. So here you see Augury's page for a company that has multiple sites. You can track the overall health of the equipment over time. You can track the cost impact, the downtime hours avoided, and also look at the machines that are in the condition that you need to look at right now. Mean time to repair, mean time between failures, and so forth. What the AI insights provide you in this case is a concise set of reliability insights for this week, right? For the next few days. And you can see the types of insights, the types of intelligence it can provide you. And this is not the full range of what it can provide. It can provide many, many other things, but here are some of the examples. For instance, you can look at recurring reliability issues across multiple assets and kind of automatically can gather that information and say, hey, there is a specific type of issue that's recurring. We understand the root causes, so you should change your program to make sure that you replace proactively a number of different bearings, in this case with solid bearings. Another one is, when we look at precision maintenance, we can have issues with lubrication. And those issues are backed by data, backed by specific faults across a number of different machines. And you can say, well, let's review lubrication practices and assign a specific lubricant to these types of bearings because we're not using the right lubricant, or we're over or under lubricating those bearings. And you can see those issues across utilizing this AI. You can also track your metrics and also track kind of the overall maintenance team skill set. And it can actually suggest training for specific courses for the team, familiarity with Augury's product, but also additional products and possibly even reliability web products in the future, right? So you can actually assign specific types of training and materials to your team, because in the background, the agents are constantly looking and monitoring what is happening in terms of the repairs, what is happening in terms of diagnostics, the health of the overall equipment, and also how quickly and how well is the team responding to those types of alerts. So let me wrap up here. This is just a glimpse into what can be done with reliability in reliability with AI. Ranging from diagnostics all the way to strategic insights and asset performance management. And of course, there's a lot more that will be done together by combining process health analytics and machine health analytics in the future. But hopefully this was good. And hopefully, we managed to learn a little bit from our experience, and we continue learning together with you as we keep progressing. So I'll turn it over back to Bob and see if there's any questions.
Fantastic, Artem. Thank you so much. I think a great place to start is I see a lot of questions around connectivity. So maybe we should just clarify a few things around cloud versus on-prem. Do you have some customers that don't want their data going up? What about that security question? So maybe let's start there about deployment and what you guys are seeing in the field in terms of the cloud versus on-prem or a hybrid.
Absolutely. So Augury is primarily a cloud solution that utilizes, of course, sensors that connect through, sensors that are wireless. We also have a wired solution for sensors, but then ultimately all that data goes through a gateway to the cloud. And we work with a wide range of customers that have traditionally been on-prem customers, including in oil and gas. We are also partnered with Baker Hughes, and if you're familiar with Bentley Nevada, they're a big partner of ours. And for a lot of oil and gas applications, we actually utilize some of their hardware for hazardous locations, and they utilize some of our capabilities. But in the end, it all goes through Augury's algorithms and AI in order to provide the same level of diagnostics, whether it's an oil and gas application or it's a food application. So we're very familiar and well versed in working with industries that have security concerns and also, kind of have traditionally had on-prem solutions, both on the machine health and also on the process health side. And of course, once we get into a specific example, we can just talk and figure out what the needs are.
Right. And what about connectivity with work management systems? I see a number of questions here about, connecting to the EAM or the CMMS system. Do we have established APIs in place? And more importantly, how does Diego and the team that's assigned out there, how do they interact when it comes to this connectivity to whatever EAM system the customer's using?
Yeah, absolutely. We have a wide range of APIs and we have a lot of different types of integrations, whether it's more kind of larger traditional, the SAPs and IBM Maximos of the world we're connected with, or some of the smaller CMMS systems that are more cloud-based. We have bidirectional integrations, right? So I showed an example where you can actually get insights on the work order itself and work order completion going back from CMMS and back into Augury. So that's a common use case for us. Another common use case for us is, an example that Diego showed where the Augury Insight diagnostic result is an automatically generated urgent work order within the CMMS. That work gets completed and it gets verified on the Augury end. So that whole process becomes automated. So we're kind of well embedded within that EAM CMMS system. And the Augury platform is really the system of choice for what exactly is happening with the machines. What are the diagnostic results? And it works well with the work, maintenance and reliability work management systems. And then it has a direct feedback back and forth. And it can also take data from them to provide those larger scale reliability insights, right, across the board.
Now, there's a lot of options out there, and in some industries, due to regulatory oversight, there's redundancy required. So is there a particular hyperscaler or cloud provider that your system operates in, or are you agnostic? It doesn't matter. It could be any of the big providers.
When we talk about, between AWS, Google Cloud, and Microsoft, right, the majority of our customers, well, first of all, we are we can do either if needed, right? But the majority of our customers are Microsoft customers. Mm-hmm. Some are Microsoft Azure, and of course, some are AWS customers, to a lesser extent Google Cloud. So we work well with whatever that is, right? That our customers require. Being primarily a cloud-based platform can service customers and the users anywhere they are, mobile, web, everywhere they go. Our mobile application, by the way, is incredibly useful on the go because it has, basically the same functionality as the web application. To go back to the office to figure out the data, you can just be right next to the machine and get those insights and drive your work.
Let's talk a bit about sensors, because I think, as you and I have discussed for years, there's sort of these parallel paths happening in terms of AI and software and technology development, but many manufacturing sites out there around the world, the idea of having to add wired sensors meant, cost and a lot of disruption. So we've seen this wave of wireless sensor technology roll out from many different providers. But I'm curious your viewpoint and what you and the team are seeing out in the field in terms of, it was all about, okay, wireless sensors, what about security? Wireless sensors, oh, what about battery life? Do I have to go replace them all the time? Can I install them myself, or do I have to pay a service provider to come in? Explain a little bit about the developments on the sensor side, because all of this is based on getting the data, right?
That's right. Yeah, I mean, that's a great question. So when we started very early on, 13 years ago, we realized that to provide and AI back then was not as much of a buzzword as it is today. But we started from that perspective, can we provide accurate diagnostics using this type of data, primarily vibration, ultrasound and other types of methods, and utilize machine learning to provide accurate insights. The problem is that it was at the time that really all those machines had to be censored out, right? And if we would have had to wait for 2 generations for manufacturing to put the right sensors on the right machines. So we said we have to develop our own hardware, and we became best in class at developing that type of hardware for sensing. It's wireless sensors, and we actually provide them as a service, right? So we give them to the customer, we deploy them ourselves, so the customer doesn't have to manage deployment. We actually have a version now that are deployable by the customers, because as customers become more savvy within the realm of IoT, they can actually manage the sensors themselves. That drives down some of the cost. And so we have provided those sensors as a service, but the actual service and the subscription that the customer is paying for is diagnostics, right? So the right machines have the right sensors, the right data in order to provide the best possible results. And that's part of the expertise that we provide as well. In terms of the sensor management and battery life, we have increased the battery life in general for IoT through our own development and working with hardware partners to something that is easily maintainable today. So our sensors today last between 5 and 7 years in terms of their battery life. Right. And we proactively replace and deploy them. We also are pushing the limits of battery life to well beyond that. Right. So we utilizing edge AI on the sensor, we can double that lifespan of the sensor. So kind of battery life from that perspective, in the past, it was a real issue when sensors lasted a year and a half for some other providers. Today, 5-7 years. That issue is not as much of a problem anymore, I think. Right. And we're seeing that with different deployments. I think another question that you mentioned was security. Of course, we have world kind of leading security protocols all the way from the sensor, fully encrypted, fully compliant. Again, we work with some of the larger manufacturers with really stringent security requirements, and we comply with all of them, both in the production floor, but also in the corporate level. So I think that is a problem that is solved and solvable for most industries as well, I would say.
Artem, I want to thank you for bringing these insights today, and Diego as well. As usual, Augury bringing us real stories from the front line of how these hard questions are being solved out in the field. This session is being recorded, so we're looking forward to not only the questions that were answered today live, but those of you that submitted questions that we didn't get to, we'll follow up with you via email. And as we said at the beginning, you'll get your certificate, your CEU, for attending this session live today. I want to thank our guest from Augury for bringing this insight today, and we look forward to you joining us on our next Reliability webcast. Thank you. Good day.
Thank you so much for having us. Thank you.